Hello and welcome back to the course Machine Learning Zero to Hero. Now we are starting a new chapter, that is chapter 3, Regression. In this chapter you will understand and learn how to implement the following machine learning in regression models such as simple linear regression, multiple linear regression, polynomial regression, support vector for regression or SVR, decision tree regression, and random forest regression. I hope you are getting excited about this because we are about to making our real machine learning model. In this section, we will learn about the simple linear regression. First of all, I will explain our dataset at the beginning. Alright, what we see here is two columns of very simple datasets consist of years of experience and salary. And basically it's telling us for a given company there's 30 observations and they took 30 random people and said, alright, so how many years experience do you have? This is not just with the company's overall years of experience of the workforce and what is the salary of that person. And then what they did is they wanted or they asked you to or they hired you as in a data center to find out if there is any sort of correlation or what is the correlation between salary and years of experience. So this is one of the case that management obviously knows that there is a correlation, that they said the salary is right. But maybe it's like a new company, maybe they only have 100 employees or something. And what you are going to be doing in this section, well, first of all, you are going to investigate what is the correlation. Well, obviously it's probably going to be more years of experience you have, the higher your salary, and we kind of can see that the trend already. But we will actually be creating a model, a simple linear regression model, which will tell us what is the best fitting line for this relationship. And if you want to look at it from the business value perspective, what is the business value out of this project apart from us? Of course, learning from the simple linear regression. The business value in here is that if the company doesn't know, if they don't have a certain set of the rules how to set the salaries, you can then go back to them with this model and say, okay, actually this is how so far you've been setting salaries, and if you are continued, then this is the model you should be applying in plus or minus a certain deviation. But you're able to tell them for the future employees, say, here you can see there's only somebody with 10.5 years experience, so what do they do? And somebody with 15 or 20 years experience comes into the company there, they can either randomly like guess a number, or they can use your model to set them a salary that everybody else then feel comfortable with. So something that, so there is the business value even in a small project like this. And let's get started to learn and practice simple linear regression. Simple linear regression is basically this formula where y equals b0 plus b1 times x. And you might recognize this formula from back in high school. It's just a formula over a trend line or a slope line on xy axis. And let's go through these variables and coefficients one by one. So this is the dependent variable. Dependent variable is something you are trying to explain. For instance, how does a person's salary change with the years of experience that he has? So in that case, what would be the dependent variable? Or maybe what grade does a student get, depending on how much time he's put into studying. In that case, what would be the dependent variable? So something that you are trying to understand how it depends on something else. Okay, so x is your independent variable. In this case, in the simple linear regression, we only have one independent variable. And this is the variable that is you're assuming that is causing the dependent variable to change. Or, as we will learn for further, sometimes the independent variable might not be a direct causal factor, but it's still there might be an implied association between the two. And in that case, you're trying to figure out this association. Then b is the coefficient for the independent variable, and it kind of how the effect or how change in x, a unit change in x. And we'll be talking about this a lot, about unit change in x and how that affects a unit change in y. So it's kind of, it's a translator or multiplier or something like that, that connects to the connector between y and x. So you can just say x is directly proportional. Well, you cannot say that y change and x is always equal to change, because y has, there might be this is a coefficient of proportion to which proportion that change is inflated or deflated. And b0 is basically is a constant, as a constant terms, and we'll talk about the constant just in a few seconds. So now let's take a look at this example in simple linear regression, because it's the easiest one to discuss. It's pretty straightforward. You can visualize it quite well. So here we got the y and x axis. Let's look at the specific example where we have experience and salary. So experience is going to be our horizontal axis, salary is our vertical axis, and we want to understand how people's salary depends on their experience. Well, what we do in regression is we don't just come up with the theory, we look at the evidence, we look at the live hard facts. Okay, so here are some observations that we have. So in certain company, this is how salaries are distributed among people who have different levels of experience. And what a regression does is, in our case, it will change to salary equals b0 plus b1 times experience. And what that essentially means is just putting a line through your chart that best fits this data. And we'll talk about best fitting in the next slide when we're talking about the ordinary least squares. But for now, this is the chart. This is the line best fits. This is the best line that approximates. For now, let's focus on the coefficient and constant here. So what does the constant means here? Well, the constant actually means the point where the line crosses the vertical axis, and let's say it is $30,000. But what does that mean? Well, it means that when b as experience is 0, so when, as you say, on the horizontal axis, when experience is at 0 in the formula, on the right you can see that the second part, b1 times experience, becomes 0. So salary equals b0. That means that salary will equal to $30,000 when a person has no experience. So, for example, somebody is fresh graduate from the university and join the company. Most likely they will have a salary about $30,000. You know, there will be some confidence intervals there, but we won't go into that right now. Just we can say that according to this model, that person we will be probably getting paid $30,000. Okay, now what is b1? b1 is the slope of the line, and so the steeper the line, the more you get the money per extra year of experience. Let's look at this. In this particular example, let's say somebody went from I don't know, maybe 4 to 5 years experience, right? So then, to understand how his salary increase, you have to project this into the line and then project that onto the salary axis. And you can see that here, for one of your experience, the person will get an extra $10,000 on top of his salary. So if the coefficient b1 is less, then the slope will be less. That means the salary increase will be less per every year of experience. If the slope is greater, then that means the experience will yield more increase in salary, and that's pretty much it. That's how a simple linear regression works. Now we will find out how to find the best fitting line, or in fact how the simple linear regression finds the line for you. So here's our simple linear regression, the same chart as previous. So now let's draw some vertical lines from the actual observations to the model. And let's take a look at one of the specific examples to understand what we're talking about here. So here, as you can see, that the red dot is where the person is sitting in terms of salary. So let's say this person with 10 years of experience is earning $100,000. So the orange line at the bottom is actually tells us where the person should be sitting according to the model in terms of salary. And according to the model, it should be a bit lower. It should be somewhere within the green dot, which is about maybe, let's say, $80,000. So now the red dot is called YI, and that is the actual duration. The green dot is called YI hat, and that is the model observational or the model value. So basically, with that level of experience, where would he be? Where does the model predict that he would be earning? And so the green line, therefore, is the difference between what he's actually earning and what he should be earning. So it should be what his model to be earning. So therefore, the green line will be the same regardless of what dependent variable you have, whether it's salary or whether it's a grade, school, or whatever. So it's the difference between the observed and the model for that level of independent variable. Now, to get this best fitting line, what is done is you take the sum of each one of those green lines or those distances, then you square them. Once you have the sum of the squares, now for you to find the minimum. So basically, what a simple linear regression does is it draws a lot of these strange lines. All this like a simplistic way to imagine. The linear regression draws all of these possible trend lines and count the sum of those squares every single time. And its records that somewhere in temporary, profile or something like that, and then it finds the minimum one, so it looks for the minimum sum of squares and find a line which has the smallest sum of squares possible. And that line will be the best fitting line, and that is called the ordinary least squares method. Okay, so that's how the simple linear regression works, and I look forward with you on the next tutorial. Enjoy machine learning and have a good day. See you.